but I'm not gonna damage my equipment.
Yeah. So, like in my car, my main electronic fuse went out, and all the electronics went out, and that fuse cost me like $250 to replace. It was a,
What?
yeah, it was a,
How many amps?
I don't know, it was, I mean, everything went out when that thing went out.
See, I might have gone to, depending on what vehicle it was, gone to Home Depot, got the same amp circuit breaker, and wired this sucker in.
Well, at the time I didn't know, so I went to
Yeah.
the dealership, because it's the only dealership in the Louisiana area at the time that serviced my Chevrolet Cobalt.
Okay, so I tried to pass out. Anyone want to see their quiz that didn't get a chance? Didn't get a chance but wants to see it? Okay. You can always ask me later.
You know, they're cheap. First off, they're cheap. They don't want to put them like this on.
Okay, I wouldn't mind doing one or two problems. We were doing some sample problems yesterday. Do you want to do one more of those?
Yeah.
Sure.
That one's interesting.
Yeah.
I don't know how it's supposed to. Can you
Redraw it.
Can you simplify that for us?
I absolutely can.
I'm trying.
He's fused pop. We need
I'm-
another one.
I told it.
I'm coming down,
Like two.
and I got another one here. I just don't know where to put that. I don't know where to put this one.
That's the easy one.
Why is that easy?
That's the one in the lower left corner. That was the one that was giving me trouble.
I just put it right there. I don't think I'm doing it right.
Maybe she'll put this on the board. My projector refused to turn off, which maybe isn't a bad thing. Oh, this is a good shot.
We're supposed to be. Your fellow Lion?
There's an interesting schematic in Lab 6. We can redraw that.
Figure 614.
Got it up here.
There's no power source.
Yeah, anyone having trouble with this one?
Yeah, I am.
Well, some of you, we've already been over this. What I finally did, because this took with me a little bit of time when I first saw this, I'm gonna write on your paper a little bit.
Yeah.
Okay, so this is positive up here, and negative is the B down below. So I'm gonna darken my ground. Remember our leads on our meters are black and red, and we usually do black as our negative. So I'm going to darken our ground, just so we get a better idea of just kind of give us a better idea what's going on. There's some ground, this is ground. This is ground. These are all one wire. This is ground. Now you look in the middle here, there's no node, there's no dot. So there's no connection there. So this, what's that horizontal line in the middle?
Bridge.
That's a ground.
That's a ground.
Yeah, because there's a node right here. It's connected. So I'm gonna put a little hump, because usually it's a little hump that kind of clarifies that there's no contact. So those are my grounds that I've darkened.
Okay.
I don't know if I have red. No, that doesn't clarify, that doesn't answer it, that doesn't make it all better?
Well, not really.
Okay, so here's my positive, I'm gonna make it, it's a little bit purple, I don't know if the purple's showing up there.
Yeah,
I don't have, this is positive, this is all positive right here.
okay, that's straight line.
Actually, where I just started was actually ground, I got a little ahead of myself, that's ground. So I get a little positive, runs down this way. Positive runs down this way. That's all positive. Okay, maybe I'll start redrawing it.
That's what I was trying to do.
So here's my power supply at the top, and I'm gonna come into a 10K. And then
It splits.
it splits. I get a 5.6K and 6.8. Behind that, after the 6.8, it splits again, doesn't it? So there's my 6 point, and I'm going to split again. And there's two resistors that follow it, a 4.7K and a 2.2K. And then those, after those, they come back together, they go to my ground. Now this, what I was hoping you'd spot is look at, what do you see that's peculiar about that 3.3K? What's its input and what's its output?
It's
They're both negative.
How do you know? Oh, I see. How do you know?
because of the grounds, right?
All because of the ground?
Yeah.
So if I were to draw this, I'm gonna put, here's the circuit, so like we've been working with a battery, a resistor, maybe another resistor, and I'm gonna draw that 3.3K. Here's a ground, that ground goes all the way back, and that 3.3K is wired just like that. It's sitting on a ground, both ends. So what's it doing?
Nothing.
Nothing. It's not doing a thing.
I don't see that.
Well, you don't see it here, but when I darken to this is ground. So the one, each end of that
Oh,
3.3, that ground is here
Oh.
and here and here. So the 3.3, its input and its output is on a ground. If I were to redraw it, I draw it like that.
Current's gonna take the path of no
Path of least resistance. It's not gonna do a damn thing.
Okay. So how would you draw that on that?
I wouldn't. It's not doing anything. As far as I'm concerned, it's not even there.
It's not even there.
Nope. It's not doing a damn thing. So then I'm gonna come over here,
First I'm looking.
and that's that schematic right there. So what am I gonna do first
Oh,
to get my total resistance total?
Oh, you're gonna add do the X1.
Yep, 4.7K, 1 over X plus 2.2, 1 over X equals, and it's in series with the 6.8. So I add those. Once I get these two combined and added to the 6.8, I'm going to pretend it's one resistor. Now I've got it's parallel to the 5.6. So I do 1 over X, 5.6, 1 over X, plus whatever that was, 1 over X, equals, I get one resistance value, it's in series with the 10K. I add that to 10K, that's my resistance total.
So you just ignore 3.3.
It's gone, yep, I ignore
Why would they have that?
it. To make you think.
No, but I mean like in real life.
No, there is no real life. This is not real life. This is pure fiction. Right there is pure fiction.
They're just trying to mind mess with
Yes.
It's a trick problem.
It's a trick problem.
You can call it a trick, but it's designed to make you think. And I would not expect you guys to spot that at this level, being new to this.
One day I'm gonna put that in a real circuit board and see what they think.
It'll do nothing.
That's the point.
Yeah.
It'll be to mess with.
Waste my time solving that one.
This is kind of like the bird sitting on the power line up above. Both of his feet are sitting on that wire, but he's there's no in or out, there's no complete circuit, it's just passing right under his feet.
What's the purpose of it?
Squirrel got in a transformer.
It's nothing, it does nothing, it's just designed to make you think. The whole purpose is to study this, to think about it, to consider what's going on here,
Oh, yeah.
to try to redraw it. But once I personally, I spent 10 minutes trying to figure out what they were doing, because I didn't expect this, but once I drew the ground, then I saw that immediately that 3.3 wasn't doing anything.
Should that ever be built in the circuit?
Nope.
As like a spare?
No.
That's just a bird, so.
No.
We
Spares
just had this conversation.
usually do spare fuses, but not spare resistors.
All right, I'm gonna trade you then, thank you.
So I get a question for you, Scott, about
Yes.
those fuses. How do those fuses just click in, or what?
The pieces I have here,
Yeah. Or do you solder them?
no, there's what's called a pigtail fuse. Let me grab one of those.
All right, so.
I don't remember if this was. I was trying to correct this.
That was, that's what I was trying to say, I had it right there.
You can call back on that H3.
Yeah.
Is that what it
So
is?
you want to think of, there's
Yeah.
two things going on.
I don't
That's regular.
understand. Anything in the language here? You have no idea.
No, this would be
I asked her, I said, this is for Bob's Crane. Yeah. I remember I told you that's where I seen him, he had one out front with a for sale sign on it years ago. So I'm thinking he's either doing one or two things. Either he's got somebody, you know, that he wants to hire.
But that's where we are.
Right.
I mean, that's where
So
we.
he put the call out.
Thought I could open that lock.
We're gonna
Have my glasses.
Especially most officers, if they're an operator on the list, you're not gonna take a job on a part-time crane, you don't wanna dig around with it. So we know what it'll do, it'll look down and see this, it'll go down to this guy, who will know this thing, to say, yeah, I got experience. And then they go to, you know, then the guy goes to, then you go down and Justin said,
Okay, so-
you guys will sign up this stuff for the union, and they send you out.
I'm gonna use my 250 milliamp first. John asked how that these fuses go in. You've seen fuses, this is what it looks like.
Maybe you don't. He doesn't really have anybody in.
And I don't know if I have a
He
reference.
also knows.
Scott, do they offer any classes in this college where you're actually working with electronical stuff? other than
There's all
hands-on?
kinds of classes on everything.
But in this college, about
I'm not sure.
electronics?
Okay, I have the fuse out of this one.
Oh, you just snap it in, huh?
See, you can see the little snaps there.
Oh, so it's pretty easy, huh?
So I press on top and I push it down in and it snaps in.
I figured what I got to lose. I just said, yes.
Wow, look at that.
You know?
The manual to these meters tell you the types of resistors that go in them. If you ever demo, and then also the value is stamped on the edge of the resistor. I don't think this will be able to show you, but
It'll be worth it.
But,
All we gotta do is work 8 days.
the value's right there on the end. One of them. You'll have to trust me, it's there.
I don't know what it takes to build to be able to say, if you guys have to get lists like that too, then change it. Maybe see.
So that meter is back in service.
Survey says.
I'm sure they have.
So,
Okay, so we were gonna do a sample problem. Okay, I don't think I brought any of mine. Do we have one in particular we wanted to work?
I have a question about
It's one
one
of the
from
one
yesterday, but I can wait till after you do something.
Which?
Was the one we actually did on the board?
Yeah.
Private session. The one where we didn't remove all bags, we had to read up the.
The battery?
No, not that one, the other one.
Okay. We'll get to
I
it.
can wait on that.
2200.
Yes.
That one? We can do this one, since it's on your,
Whiz?
it's up here, we might as well do it. We can just get total resistance. So, 4,700,
Got 2.6.
1 over x plus 2,200, 1 over x is how much?
I guess somebody has to do that.
1.448.
It's 1 point.
1498.
1498 ohms. These two combined, they're parallel. So the resistance is going to be lower than the lowest resistance. Now I add it to 6,800. Eight, 9, 12, 8298. Okay, but when I add it to 6,800, I get 8298. So now this whole area right here, this is, I've got 10K, 5,600, and then I've got 8298. So now we need to do 1 over x with the 5,600 and the 8298. 3343. Now I just add 10K.
Yeah.
So my total resistance should be 13,443 ohms.
Shazam. Shazam.
Yes. Okay, so let's do let's see, we have, it's not too unlike what we have. Oh, yeah. So we have one resistor. We have one resistor up here. Which one of those are we gonna do? I don't have my sheet, so you're gonna have to help me.
Oh, which street?
One of those that we didn't do yesterday.
Oh,
It has one out here, if you remember that. That's R1, R2, R3, R4. Is there a 5 or 6?
Yeah.
Both?
oh my goodness, it's so much.
Okay, so the top one, 24 volts. And we come to R1, which is how many ohms? 350 ohms. Okay, so we come to, after R1, everything travels through R1. There's no sneak arounds. We split it R2 and 3. So R2 is how much? 1,500 ohms, and R3, 250. And then there's a resistor that immediately follows, R3, or 2 of them actually. So R4 and 5 are what? 175?
175 and then 75.
And then 75. That's supposed to be ohms. It's not be up here. Then they come together, and then they go through one more resistor, which is R6, which is how many ohms?
175.
175. Okay, so it's all in ohms. Is this difficult?
No.
First thing we're gonna do is add these three together.
You get 500.
Okay, so I've got, I guess I can just erase. Let me redraw. 500 ohms, and then 1500 ohms, and 350, and
Zero.
175. So we're gonna do 1 over X for the midsection,
375.
375. So I'm gonna just erase this and change it to 375.
You get 900.
900 ohms.
And then you can get your current.
I got 24 volts, so my current
24 divided by 900 is
Yeah.
0.02666.
0.02666 amps.
The same for R1 and R2, R6.
So yes, R1 and R6 and the total for the circuit are going to be 0.02666 amps. I can do a grid if you want, but I think we got it. Unless somebody's still having trouble visualizing this. I don't know what else to tell you. You'll have, okay, so after that, and we can do the grid if you want, but we got all of our resistances. We took the voltage, we got a total current, and that total current is for R1, R6, and the total. So now we can take the current and the resistance and get voltage. So we're gonna have a voltage drop in here and a voltage drop in here just using the current. The current, we know the current here, we don't know the current in here, but we know the current for this one and this one, and we have the resistance also. So taking the current times resistance will give me volts. So I'll have a voltage drop
23.
for here and in here. I'll have those voltages. I subtract them both from 24, and that's going to give me the voltage in the middle. And that's only going to affect this 1500 because it doesn't share the voltage. So whatever voltage drop is goes with that 1500.
So like the bottom one is 4.665 volts.
4.665.
Yeah, and then you go 24 minus
How about up here?
4.665.
I
You
need
get
that voltage.
9.33.
9.33 volts. Now I can subtract both of those from 24.
You get 10.
10 volts in the middle. So now this R2 is going to be 10 volts, but 3, 4, and 5 are going to add up combined to 10 volts. So what I need is more information to get for the right side.
Can you call 3 of them and then divide by the?
I can add them all together. Actually,
But you already have the current, right?
I need the current, and I was thinking I was going to get current that way, but I'm not.
So you get 10 divided to get the current. You go 10 divided by 1500.
Okay,
You got 10?
you're right.
You add them all up, and you get 10 volts.
Yes, but I still need to break them down. There are ratios. I can do the ratios, but the easiest way is since this 1500 ohm is 10 volts, I can get the current.
0.00666.
For all three.
0.0020?
66.
666.
Okay, so now all I have to do is subtract this from
From your
266.
the
Zero.
two, so it's 0.02. So my current down this side is 0.02 amps.
Yeah.
This is my river. I have two paths. I know how much is going over on this side, and I know how much is going in front of and back of. So the difference, I subtract this current from my current up here, and that tells me how much is going the other way.
You get some of these like it has to do on the airplane, like instead of the bubbles.
Floating flight attendants.
Yeah.
I used to fly a lot, you know, and I would fly most of the time I flew first class. I was on business, I would wear regular clothes. The flight attendants flirted with me all the time and tried to sit on my lap during the movies.
Oh, jeez.
But unfortunately, it was never the females.
Oh.
Hey-o! That just went the wrong way.
There, you're gonna do the curve.
You have to go that way, right? You can't add them up like you were saying, and then.
Add 'em- okay, if I add them all up, I'll get a total resistance in here. Yes, yes, you're right. I can add them, all three of these together, get a total resistance and use the 10 volts to get the current there. So yeah, you are correct. So I can get that current both two different ways. Everybody get that? I got this current over here with the one resistance value in the 10 volts. But if we add these all three together,
10 volts.
10 volts divided by that resistance will give me the current for that leg also.
500.
It's 500?
Per volts, 5 volts, 3.5 volts, and then 1.5.
Oh, okay.
Is it correct then to assume, see that 0.0266 amps on top? We can
Yes,
safely say that that's 0.02266 on the bottom as well, right?
yes. It's gonna be, because this is the river, everything passes through here, so that's the total current.
Alright.
So that's the 0266, same with R6, and then the total.
Yeah, because you could just add the 0.2 plus the
You see it?
0.00666.
Had I not known that, had it given me, and many of these do, when they've got a mixture of, they don't give, when it's not an all ohms problem, they're always gonna give you a current here or here. I mean, that's the way they've been doing it. Yeah, I could give you a current here and here, and you could still figure it out, because this current, I'm given this current, it's gonna be this one in the total, and I subtract this, it's gonna give me the other side.
How do we get the 0.0066
You want to
again?
redraw that?
Okay, we got the 0.066 from the 10 volts of the 1500 ohms. So I took I divided the voltage of 10 volts by point zero, I'm sorry,
15.
by 1500. 10 volts divided by 1500.
Yeah, that's how he's good.
Okay, so we've got one more in there that we haven't done. And then we'll go back into lab. So the other one is probably not all resistance, is it? We have one more we didn't do?
Yeah, there's
And is it all ohms?
yeah.
Or is it a mixture?
That's all ohms.
Do a mixture.
Do we have one that we haven't done that's a mixture?
I did the mixture yesterday. Look, this one's
Yeah, no, but
I don't have it.
the mixture, we did it.
Which one are you This is the one I just did right here.
Did not bring everything with me tonight.
I'm with you.
I don't have, unless you wanna redo one we've already done, I don't have one handy, it's a mix.
Did we do this? We just said this one, right? You said that.
Which was,
Got this last one here.
and is it a mixture? Or it's all ohms?
You wanna do a mix? I think we're done with mixes. The last mix was yesterday. This one.
We're gonna have to do all ohms,
This one's a mix.
unless
There's no new mesh formation, right? Just the four that we're working with?
everything we've covered, you'll see on the test. You're not gonna see anything new as far as these schematics, except that H-shaped one will have an additional resistor on top.
Okay.
And it's not difficult, you just add them together, treat them as one, and you'll end up with a current up there eventually. And you'll be able to, but it's gonna all be straight ohms.
Do you make one up?
You know, I've tried to make those rectangular ones up, and they don't, you can't just make them up. We got lucky on the other one, the one we were missing was the voltage, and that one we found we could change.
Yeah.
And it's not surprising, I could take that whole circuit and put it on a 12-volt system, and put it on, or put it on a 24-volt system, and it would behave differently. Let me see, there is a chance.
You try doing everything in proportion, like divide all the numbers in half or something?
You can do that, but what I was gonna do is, if I go to Google, I think I could probably pull one up pretty quick. And the other option would be to do one we've already done, just, you know, just don't look at, don't follow through it. Let me check the internet real quick, it's not, those things are not that uncommon. There's Ben.
No, like he's not actually doing this. The fucking burns out there. So he has to do it. Oh, he's amazing. Yeah.
How about that one?
What's that? Look at the shit and it's like, he's not helping out.
We got one here, oh, that's a long, yeah, you know, I may find one, here's one right here, but it doesn't have any values in it, but that's got a bunch of resistors in it. It's gonna be tricky to find one that's got values and is a mixture of resistance and everything else.
Switch.
See that one?
Years.
Okay, well, I think we're gonna have to do one that we've already done, and I don't think, I know my memory isn't that great. The process is still gonna be the same.
How would you draw one of those, like, it looked like, you know how you draw your river right there, but it looked like it just crossed diagonal from one end to the other. How would you draw something like that?
You saw about when you saw it here,
The one you just had up on the board. I mean, it was like square and then it had
some
a
diagonals.
cross diagonal with a resistor in the middle. How would you draw that?
Yeah, there was some with some diagonals. Which was your question in the back?
It has that whole, if R2 opens, the current total equals, and I remember you pointing it out yesterday that if you drop one of the resistances, then at that point it's, the R2 is the X over, or it's X minus to the minus 1, plus, so basically it's minus the 350 is.
It says if number 2 opens.
Yeah, and it's on that block.
Okay, if number 2 opens, it's going to be a series circuit.
Yeah.
the resistors won't change and the voltage, the source voltage won't change.
Okay.
So you'll just do it all over again, but you'll add all the resistors since it's straight series
Okay.
and get a new current.
Oh, I got it.
Just like that was never there then.
Yeah. It will change. I mean, that's what will happen. You'll lose that parallel circuit. The resistance will increase
Yeah,
because any type of parallel decreases.
but you just redo it as a series.
Yes. Um, You were looking at one, I know probably, you were looking at this one, something like that?
Yeah, how that be drawn? What's or is it just a?
Can you look at one that we did yesterday that
Yeah.
I was trying to figure it out today and I got stuck on it.
Yeah, let's do that one, since you've got a question on it. Really, what I was planning on doing was going over the problem on the quiz, but I think you guys are beyond that. There were a couple people that had a little trouble with it, but not much. Okay, Scott, so the one you had, R1 is, how many volts is it?
1.8 volt?
The whole circuit?
No,
What's the total? Is it, oh, okay, so that, it's a mixed.
yeah, it's mixed.
Okay, so let me draw it out. So what does it give us for the power source?
Power is 120 milliwatts.
120, I'm gonna go 0.12 watts. R1 is giving me what?
1.8 volt.
1.8 volts. R2 is giving me
7.5 milliamps.
is that right? 0.75 amps. And then R3 was giving you what?
5.125 milliwatts.
Okay, so I convert that to 0.005.
1500.
125.
125 watts. And then R4,
2.5 milliamps.
and then down here is R4 if I'm not mistaken.
R5.
R5, 2, 3, 4, yeah.
3.75 volts.
And then we have one here.
Yeah, R6 is 2.7 volts.
Okay. So this is pretty close to what you'll see on the final for this class. And probably we got a test, what, 2 weeks from tonight or a week or Monday? When is that? It's coming soon. P, power, current, resistance, volts, or 1, or 2, 3, or 4, or 5, 2, 3, 4, 5, or 6. Total. Taking me a moment. I know you guys have reworked this, but okay, so I'm gonna write down what was given to us. R1 is 1.8 volts, 0.075 amps. 0.05125. Oh, that's watts. Rats. Okay, what goes here? R4, 1, 2, 3, 0.025. So we know all our amps right off the bat, right?
Yeah.
All our currents.
So they're all going to be .0025 except for that R2, right? And the total. It'd be different.
One of the.
Okay, so do I need to redraw it? I don't mind. There's our
It's up to you.
1.8 volts. It splits. We've got 0.0075 amps over here. We go down the other side. We've got 0.005125 watts, 1.0025 amps, 3.75 volts. That's 2, that's 3, 4, and 5 resistors. R6 is 2.7 volts. Okay. So everybody should see right off that we have all the currents. Because we have the current down this side, 0.0075 amp and 0.025 amp.
0.1.
It says 0.1 in there?
No, that's the total.
Okay, 0.1.
That's for.
Okay, so we know
Or 6 and the total.
we know how much is going down each path. We got some of it here, some of it here. We add them together. We've got
But
what's
for,
here.
just for clarification, for current, all the way, they're all .0025 except for R2 and the total?
R3.
R3,
Okay. We have the current for R4, and these are in series
Yeah,
with it.
those are all gonna be the
So
same.
these are all going to be the same.
0.0025, right?
0.0025, 0.0025.
Okay,
The other one is.
We got that.
got that.
So now my current comes down, it splits, comes back together.
Okay,
I know how much is traveling on each
so
side.
you can add those.
I add those together, and that's going to give me the current here and here, which also is going to be my total. So I have a 0.01 amp.
Okay, that's what I should do.
0.01 amp. R1 0.01 amp. R6 0.01 amp. R6 because it's out here by itself. Everything goes through here. Is that me? Sounds like our break time.
Yeah, someone said. Yeah, but you're a code.
That's break time. Let's go a few minutes. That's just, it's 10 till, so let's just finish this. Okay, so currents. Everybody, any problems with how we're getting current? And then my total down here, 0.01 amp. I have two values for everything except R2 and R4.
Your total voltage, bottom, 12.
12 even? So I know my voltage up here now is 12 volts. I know my current, and I've got a voltage for R1. Actually, I've got my voltage. I'm going to use that right now. Or I'm going to start to. Yeah, no, I know my voltage down here. 2.7 volts, 1.8. So subtract those two numbers from 12 volts, and we've got our voltage for the middle section.
No. So. Sounds not bad.
Take your word for it. So that 7.5 volts is
R2.
R2s.
And a total for R3.
And then these three here will equal 7.5 combined.
So you can go ahead and subtract that 3.75, and you know you.
Yes, I can, with these two values, I can get my voltage.
Oh,
And then subtract those two numbers.
I've got power and I've got current.
Yeah.
You can figure out.
Power divided by current will give me volts.
So,
Power divided by current.
205.
2.05, 2.05. So now I know that these three numbers add up to 7.5. So all I've got to do is subtract those two from 7.5. I've got my missing number. Anyone?
How'd you get 7.5? You went to
Okay, so the 7.5,
I understand. You get
we,
12.
do you got it?
You got
We were
12.
given 2.7 and we were given 1.8.
No.
We figured out our 12 volts.
And how'd you figure the 12 volts?
We got the 12 volts because we were given 0.12 watts and we figured out the current. Remember, at the very beginning, we figured out all the currents.
So we
So we
got
took
12
these two numbers and got our 12 volts. It's a 12 volt circuit.
and you subtract it.
So they gave us the voltage for 1 and 6. So it was very simple to subtract those from the 12 volts to get our 7.5 in the middle. R2 does not share that 7.5. It gets it all. These three share it. We were given our R5's voltage, and we figured R3's voltage with the current we calculated. It gave us the wattage. We figured out the current. That gave us a voltage. So Kirchhoff's law applies inside this little area. These three combined are going to add up to 7.5. That 7.5 volts is from here to here, and from here to here. Since these are series, all three of those voltages will add up to 7.5.
On a 5 resistor, you're only gonna subtract the R1 and the total and get your R2, right? On a 5 resistor?
The R5, they gave us the voltage.
No, I'm saying you only have 5 resistors.
I had 5, 1, 2, yeah, I had 5 resistors.
No, you have
No, I had
6.
6.
But I'm saying when you have 5,
1, 2, 3, 4, 5. Yes, when I had 5.
you're gonna only subtract R1 from the total to get R2. Whereas here you have to
Are you saying
add
which one, if I have 5, which one are you saying is missing? This one?
the R6.
Okay, then I wouldn't have had this 2.7 volts, so that wouldn't have been here. I was given my 1.8,
So then you don't have it. Okay, never mind.
but that would have changed everything because once I figured my 12 volts, if it was indeed 12 volts, I would have taken my 1.8 from 12 and that would have been, this number would have been
Right, that's what
higher.
I meant.
This number would have been higher. So again, narrowing it down, once we got this one was given to us, the 3.75, and we figured out the two volts after we used the current and the given power.
1.7.
So 1.7 in there.
Now, on that column, if you just take the circuit that's in series, that alone will add up to the 12, right?
This,
Without the parallel circuit.
well, what I have to do is treat this middle section as though this were the circuit. I don't know, I don't want to confuse you by that. But that center section I treat this way because this center section sees 7.5 volts. R2 sees 7.5 volts. It knows nothing of the rest of the circuit.
Right.
So I kind of isolate R1 and R6 when I work the center section. So again, 2, 3, and 4 have to add up to 7.5.
Okay.
This voltage was given. This one we figured out.
Right.
So that all we had to do is subtract those two values from the 7.5 to get the missing voltage.
Oh, okay.
That was probably where you were down to the end. We're having trouble.
Yeah.
That's why I drew. That's why I drew this little here. That's 7.5. This is the 2, and these 3 are parallel to that 2. Parallel circuit, the voltage is the same. But these are in series within that parallel circuit, so they share that 7.5 volts. You get, yes?
Okay, on this one, there's a question, But where the second resistor would open, is that the same thing where you add all the resistors?
Yes, because the resistors, and we didn't do resistance, but we easily could,
Yeah, right.
and I'd like us to go to break.
Yeah.
Um,
Okay,
If-
well, actually.
if R2 were to go away, open circuit.
Yeah.
All we have to do is create a break and it no longer exists.
Serious.
It's straight series.
Okay.
Our voltage, our 12 volts, not gonna change.
Right,
If it's an automobile, an aircraft, whatever, that's a fixed value. And our resistors are physical components, so they're not gonna change. The voltage drops will change because the current will change as a result. So in that instance, if R2 goes away, I will simply add 1, 3, 4, 5, and 6 and get a new total. A total resistance which I will work with my 12 volts to get a brand new current. Why don't you guys take a break?